class 11th, subject physics, 11th chapter, electric currents through conductors. From the chapter, let us see cells in parallel. So, in parallel combination of the cells are connected in different electrical paths. So, for parallel combination of cells, the electrical paths will be different for different cells. The positive terminals of all the cells will be connected together to a common point, and the negative terminals of all the cells will be connected to another common point, so that the two cells, if they are connected in parallel, then they will be connected between two common points A and B. When the cells are connected in parallel, the total current in the circuit will get divided as I1 and I2. I1 will pass through E1 and I2 will pass through E2. Let R1 and R2 represents the internal resistances of these cells. Similarly, phi A and phi B be the potential at the points A and B respectively. And therefore, if you consider this cell E1, then the potential difference across the terminals of cell of EMF E1 will be given as phi equal to phi A minus phi B. That will be equal to phi A is nothing but E1 minus phi B is nothing but I1 R1. And therefore we can write phi equal to E1 minus I1 R1, or from this E1 minus phi will be written as E1 minus phi equal to I1 R1. From this equation, I1 will be determined as I1 equal to E1 minus phi upon R1, equation number 1. This equation gives the current flowing through cell of EMF E1. Similarly, if you consider second cell of EMF E2, then the potential difference across the terminals of cell E2 will be given as phi equal to phi A minus phi B, similar to that of cell of EMF E1, because both these cells E1 and E2 are connected between two common points A and B, and therefore phi will be equal to phi A minus phi B, but the values of phi A and phi B will be different because of cell of EMF E2, and it will be E2 minus I2 R2. So this I1 R1 and I2 R2 will be nothing but phi is equal to IR, that is potential difference across the plates of the cells, and therefore from this equation we can write E2 minus phi will be equal to I2 R2. From this equation, I2 can be determined as I2 equal to E2 minus phi upon R2. E2 minus phi upon R2, equation number 2. This equation gives the current flowing through cell of EMF E2. Now, as the cells are connected in parallel, we know that current is divided, and therefore total current I will be equal to sum of I1 and I2, that is I1 plus I2, and therefore the total current I will be written by using equation 1 and 2 as E1 minus phi upon R1 plus E2 minus phi upon R2. Now separating denominators for these two terms, that is E1 by R1 minus phi upon R1, E2 by R2 minus phi upon R2, we will get E1 by R1 minus phi upon R1 plus E2 by R2 minus phi upon R2. Now, taking together the terms of E1 and E2 and phi, we can write current I is equal to E1 upon R1 plus E2 upon R2 minus phi is taken common, into 1 upon R1 plus 1 upon R2, equation number 3. So this third equation gives the total current I flowing through the parallel combination of the cells. So now from this relation we can write as I is equal to E1 upon R1 plus E2 upon R2 minus V into R1 upon R1 plus 1 upon R2. Therefore, from this, V into 1 upon R1 plus 1 upon R2 will be written as V into 1 upon R1 plus 1 upon R2 equal to E1 upon R1 plus E2 upon R2, E1 plus R1 plus E2 upon R2 minus this I, total current I. That will be simplified as, that will be written as, by taking the cross multiplication of this bracketed term, we can write E1 R2 plus E2 R1, E1 R2 plus E2 R1 upon R1 R2 upon R1 R2 minus I will remain as it is, and therefore this will be the value of V into 1 upon R1 plus 1 upon R2. Now this bracketed term will be again simplified as V into, again taking the cross multiplication, R1 plus R2 upon R1 R2. That will be equal to E1 R2 plus E2 R1 upon R1 R2 minus I. Or from this, phi will be written as phi equal to E1 R2 plus E2 R1 upon R1 plus R2. So this multiplication term will be shifted towards right so that it will get divided. So for this we will get E1 R2 plus E2 R1 upon R1 R2 into R1 R2 upon R1 plus R2. R1 R2 will get cancelled, and so that we will get E1 V2 plus E2 R1, E1 R2 plus E2 R1 upon R1 plus R2 minus I into R1 R2 upon R1 plus R2. So this will represent again potential. This term will also represent the potential, that is E1 R2 plus E2 R1 upon R1 plus R2 minus I into R1 R2 upon R1 plus R2, equation number 4. So this equation will give us the value of potential phi between the 2 points A and B. So this will be the equivalent potential. And now if the two cells are replaced by a single cell, if the two cells are replaced by a single cell connected between 2 points A and B with EMFs E equivalent, EMF will be E equivalent and internal resistance will be R equivalent, then we can write phi equal to E equivalent minus I R equivalent. So potential phi between the 2 points A and B will be equal to equivalent EMF, that is E equivalent, minus equivalent potential, that is I R equivalent. Let it be equation number 5. So now comparing equations 4 and 5, we can write comparing equations 4 and 5. So by comparing this equation number 4 and this equation number 5, we can write equation number 4 and equation number 5. From these equations we can write equivalent EMF E equivalent is equal to equivalent EMF, because this is V, this is V, so that left side of equation 4 and 5 are same, therefore right side must be same. Therefore this term will represent equivalent EMF and this second term will represent I into R equivalent, and therefore comparing this we can write E equivalent is equal to E1 R2 plus E2 R1 upon R1 plus R2, and R equivalent, that is equivalent internal resistance, will be equal to R1 R2 upon R1 plus R2. But when the two resistances R1 and R2 are connected in parallel, at that time their equivalent resistance will be given as 1 upon R equivalent equal to 1 upon R1 plus 1 upon R2. And therefore these are the values of equivalent EMF and equivalent internal resistance. And therefore from this equation we can write, if you take the ratio of E equivalent to R equivalent, E equivalent to R equivalent, if that ratio is taken, then we will get E1 R2 plus E2 R1 upon R1 plus R2 divided by this R equivalent. If we divide this by R equivalent, then it will be multiplied by R1 plus R2 upon R1 R2. It is divided by R1 R2 upon R1 plus R2. Therefore, it will be multiplied by R1 plus R2 upon R1 R2. And if it is multiplied, then R1 plus R2 and R1 plus R2 will get cancelled. And therefore, after cancelling this, we will get E1 R2 plus E2 R1 upon R1 R2. This will be written as, separating denominator again, from this R2 R2 will get cancelled. Therefore we will get E1 upon R1 plus, again from this R1 R1 will get cancelled, we will get E2 upon R2, equation number 6. So this will give us the ratio of E equivalent to R equivalent as E1 upon R1 plus E2 upon R2. Now instead of that, instead of only two cells, if n number of cells having EMFs E1, E2, E3 up to En and internal resistances R1, R2, R3 up to Rn are connected in parallel, then for n cells we can write 1 upon R equivalent, their equivalent resistance 1 upon R equivalent equal to 1 upon R1 plus 1 upon R2 plus 1 upon Rn. This relation already we have seen, that when the resistances are connected in parallel, then the reciprocal of their equivalent resistance equal to the algebraic sum of the reciprocals of individual resistances. And the ratio E equivalent to R equivalent, E equivalent to R equivalent will be given as E1 by R1 plus E2 by R2 plus En by Rn. And now let us see the next point, that is advantages and disadvantages, advantages and disadvantages of combination of cells. Now we know that the cells can be connected in series as well as in parallel, and therefore when the cells are connected in series, the advantages of it will be, the cells connected in series produce large resultant voltage. So resultant voltage will be large when the cells are connected in series, and therefore to prepare the batteries, the number of cells are connected in series so that the resultant voltage will be large. Secondly, the cells which are damaged can be easily identified and can be easily replaced in case of series combination. So when the cells are connected in series, then cells which are damaged can be easily identified and hence can be easily replaced. Now let us see the advantages of cells in parallel. The advantage of cells in parallel is that the current will not break open even if a cell gets damaged or it is open. As the cells are connected in parallel, therefore if any electrical path is open or it is disconnected, other paths will be then connected in the circuit, and hence the current will not break up open even if a cell gets damaged or it is open. Now let us see disadvantages of cells in parallel. What are the disadvantages of cells in parallel? The disadvantage of the cells in parallel is the voltage developed by the cells in parallel cannot be increased by increasing number of cells present in that circuit. The voltage developed in the cells or in that circuit in parallel combination cannot be increased by increasing number of cells present in the circuit. In case of series combination, the voltage can be increased by connecting number of cells in series, but in case of parallel combination, the voltage will not be increased in that circuit. So these are some of the advantages and disadvantages of series and parallel combination of the cells. And now let us see the next point. After these advantages and disadvantages, let us see types of cells. Types of cells. Generally, the electrical cells are classified into different categories like primary cells, secondary cells and fuel cells. Primary cells, secondary cells and fuel cells. Now let us see one by one all these three. First of all, we will consider primary cells. So these cells cannot be recharged again. The recharging of these cells is impossible. That is, primary cells are not recharged again. It can be used only once. As they are not recharged, therefore they can be used only once. These cells are having low cost and can be used easily. Operating system for these cells is very easy and they are having low cost, but these cells are not suitable for heavy loads. If load is heavy, then these cells are not suitable there. For example, dry cells, that is our battery cells, alkaline cells are the examples of primary cells. The battery cells cannot be recharged and therefore they are the primary cells. Now secondly, secondary cells. These cells are rechargeable and can be used again and again. So if you consider these secondary cells, they can be recharged and therefore can be used or reused again and again. The chemical reaction in these cells is reversible and that's why they are recharged. These cells can be used for heavy loads. Instead of primary cells, secondary cells will be used for heavy loads. For example, lead acid cell, fuel cell, solar cells, these are the examples of secondary cells. Lead acid cell, fuel cell as well as solar cells are the examples of secondary cells. And now let us see third one, that is fuel cells. Instead of lead acid batteries, the fuel cells are used as fuel in case of fuel cells vehicles. Fuel cell vehicles can be run with the help of these fuel cells instead of lead acid batteries. In short, these fuel cell vehicles are called as FCVS. FCVS. And these vehicles are operated by using these fuel cells, so that fuel cells will provide the power to these vehicles. Now, when that fuel in that fuel cell is burnt, at that time hydrogen is the fuel used in these cells. So if you consider the fuel cells, the fuel used is hydrogen, and when the burning of this fuel takes place, at that time the byproduct after burning is the water. So after burning, the byproduct of this fuel will be water, and these vehicles do not produce pollution, so they are very useful. Less pollution will be produced with the help of these fuel cell vehicles. So this will be regarding different types of cells. Now at last, in short, let us see what is potential difference and EMF of the cell. What is the actual meaning of potential difference of the cell and EMF of the cell? So the potential difference of the cell is defined as the energy supplied by the cell to overcome the external resistance only. The energy supplied by the cell to overcome the external resistance only is called as potential difference of that cell. On the other hand, the EMF of the cell will be defined as the energy supplied by the cell to overcome the external as well as internal resistance of that cell. So the energy supplied by the cell to overcome external as well as internal resistance of that cell is called as the EMF of that cell, and hence large amount of energy will be supplied by the cell to overcome the internal as well as external resistance, and that's why the EMF of any cell is always greater than the potential difference of that cell. So E will be always greater than phi.